Alright, so this video is going to be part 2 of surface area problems with parametric equations. So we have our curve up here, x equals 9 plus 2t squared and y equals 4t from 0 to 2, and we're revolving this curve about the x-axis to get a solid. We're finding the surface area of that solid. This is the equation for surface area. So we can first find dx dt and dy dt, right? So dx dt is going to be equal to what? Well, take the derivative here, you're just going to get 4t. And what will dy dt be? Well, that's just the derivative here, which is just 4. Alright, so nothing too bad there. Okay, now we can plug into this equation here. And we already know our bounds, by the way, that is from 0 to 2. And our y is 4t. Okay, so now we have the square root of dx dt squared. That's going to be 16t squared, right? Taking the dx dt from over there. And our dy dt squared will be 16. Cool. So now we can factor out that 16, right? And when we take the square root of 16, we get 4. So we're going to get that the surface area is equal to 8 pi, the integral from 0 to 2 of t. And like I said, this is going to be times 4, and then we're going to have rad t squared plus 1 dt. Simplifying this a little bit further, we got to take that 4 out. Surface area is going to equal 32 pi, the integral from 0 to 2 of t rad t squared plus 1 dt. Great. So now what do we do? Well, this is obviously going to be a u substitution. So u equals t squared plus 1 du equals 2t dt. Divide by 2 on both sides, and you're going to get that du over 2 equals t dt. Okay, so now that we have our two substitutions, right, we can just substitute in here. We get surface area is equal to 32 pi. That's going to be over 2, right, on the outside. We have our integral. We need to figure out our bounds still. Of this is going to be just rad u du. Okay, so what are our bounds going to be? Well, when t equals 0, what happens to u? Since u is t squared plus 1, if we have t equaling 0, that's just going to be that u is 1. And if t equals, what's the other bound, 2, then u will equal 2 squared plus 1, which is 5. So now we have our new bounds right here, 1 and 5. Okay, so now we just integrate, right? That's the last step before our evaluation. Okay, we get 16 pi times 2/3 u to the 3/2 evaluated from 1 to 5. Alright, now we multiply 16 by 2 again, so we're going to get 32 all over again. We get surface area is equal to 32 pi over 3. And now we have u to the 3/2 evaluated from 1 to 5. That's just going to be 5 rad 5 minus 1 rad 1, which is just 1. And there you go, you have your answer. Alright, really nice when this y ends up, providing a nice u substitution for this integrand. Alright, as it did in this case. So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for surface area with parametric equations, and the next video in the series. See you soon.